Okay, we've learned how to actually take some data and look at it visually with the different graphs. Now we're going to look at how to summarize data. So we have a big, large data set, and we want to be able to look at it and look at these summary statistics that we're going to go over. And one of the big things is looking at, do we see skewness in the data, like is most of the data to one side or the other when we look at a distribution. And definitely watch my videos because all of these calculations can be done in Excel very quickly, actually. So if I'm looking at the measures of center, right, where is our data centered around? We look at the mode, median, mean, percentiles, and quartiles, where the mode is just the value that shows up the most frequently. So as you can see in a graph, it's the highest value. So maybe the movie of this summer that sold the most tickets, okay, something like that. There can not be a mode if there's nothing repeated. Okay, so if you have no values repeated, then there may not be a mode. There could be more than one mode. You could have bimodal or even multimodal with more than two modes. The median is the value in the middle. There's lots of ways to discuss the formula to find the median, but I just put the data in order. That's important, from lowest to highest. If you can get an exact middle value, okay, so if you think about it, if you have three numbers, there's one middle, right? But if you have four, there's two middles. And so if you have an odd number, it's just the exact middle. If you have an even number of data values, you take the two middle values and you average them, and that's the divide by 2 here. And then the mean is the average. You take something, you add them all up and divide by the number of values. Here are some of the formulas, and as you're going to see, you really need to get down the symbols in this course. It's probably the hardest part in the beginning, that if I'm looking at an entire population, we use the Greek letter mu. The sigma means to sum all of the data values and then divide by the population size. So capital N is population size. Same thing, sample mean, you take and you add everything up, but now you're dividing by the sample size. So population size, capital N, lowercase, sample size, little n. And so this is X bar to find the sample mean. A lot of times, we report averages only, but if you have data that is skewed, like think about salaries. There are people that make a whole lot more than I make, right? And so the data might be skewed. So typically we like to look at the median. That helps us actually see what's really going on in the center of our data set, where the mean can be affected by a very, very large value or a very, very low value, like mega zero on an assignment, right? And that affects your average. Percentiles, so we're still looking at central tendency, but we divide things into 100 parts, a percent. A lot of times you'll see things reported where your scores was in the top 99th percentile. And to be able to calculate these, remember N is the population size, whatever percentile that you want, this gives you your index number. So this is simply your index number. If you get a whole number, then you average the ith and the I plus 1. So in other words, my index number plus 1 and average. Otherwise, you're just rounding up to the next largest whole number. So as you can see here, if I wanted an 80th percentile, this says my index number would be 992 placement. Okay, so in other words, I'd count to 992 values. But because it's a whole number, we would actually average these. Quartiles are the same thing as percentiles, except they're specific in quarters. So quartile 1, 25%, quartile 2, 50%, quartile 3, 75%. All right, and then we want to look at measuring variability. So in other words, how spread out is the data? Pretty much everybody This yellow one pretty much together, or is the data more spread out? The most common measurements of variability, definitely standard deviation. That's the one you want to get down. We also look at the range, we look at the interquartile range and the variance. So the range is just the difference between the largest and smallest value, but as you see here, it can be affected by very extreme values. The interquartile range, you find your quartile 3 and subtract it minus quartile 1. And that gives you your middle 50% of your data. Box plots are very important to be able to visualize data because, of course, this moves along whatever values we're looking at. But they call them typically box plot, and whiskers because the whiskers here are coming out showing the lowest and the highest value. This box right here, so the width of the box is my quartile 3 minus my quartile 1. And then I can see this median can move around. You'll be asked to find the 5-number summary, which is the minimum value. This is a box plot that's showing outliers, values that don't seem to really belong. And here is how you can calculate an outlier. So in other words, if I find my quartile 1 and subtract 1.5 times my IQR, anything below that would be an outlier, or plus would be above an outlier. But my 5-number summary, the minimum, quartile 1, the median, quartile 3, and the max. So when you're asked to find those are what you're looking for. You can see these either horizontally or vertically. Once again, they just show you the distribution of the data. The side-by-side ones are pretty cool because it can show you one group, meaning, I mean, look here, from quartile 3 to quartile 1 has a lot more data than this one has. And so these are nice. They're not real easy to do in Excel, but there are some websites out there that you can create these very quickly. All right, deviations from the mean. So the mean, the average. How far are you above the average? How far, and you always want to know that, right? What was the class average? So I know if I was above average or below average. And once again, as you can see, this is going to depend on the variability. So we're looking at how much you deviate. Okay, and this is certainly good for interval or ratio data, if you remember from the last section. And we find these deviations from the variance. Okay, so we have a population variance and a sample variance. Sigma squared, population variance, S squared, sample variance. How far away a data value is from the mean. So we're doing every single data value, adding them all up. So that's the population mean, and then divided by the population size. Same thing here, nothing changed except population mean becomes sample mean. And this one you have to be careful for the sample variance. We divide by the sample size minus 1. As I mentioned, we tend to really like the standard deviation better. All it is this looks exactly like what you just saw here, but we put square roots on it. So sigma, the population standard deviation, S, the sample standard deviation. Formulas are the same, but square root. Why do we like this one better? Because the variance, if we were talking in dollars, would give me squared dollars. This actually would give me the same units as my data set. So we definitely like to report things with the standard deviation because the units are the same. The empirical rule is a set-in-stone rule. Always have students ask, are these percentages always the same? Yes. So this is a rule of thumb that if you're above and below one standard deviation of the mean, that encompasses 68% of your data. If you're below and above 2 standard deviations, so 2 times your standard deviation, that's 95%. And then also 99.7%. Now I show an example because this is a very important rule. I have a video that shows how to actually work something out with the empirical rule. Then we're going to get into, and this is very important because you're going to see it the rest of the course, with z-scores. All a z-score is we standardize our data. Okay, so we standardize our mean to 0 to this z-score, as you're going to see later, to look probabilities up in a table. But what we're doing when we translate our mean to 0, this will give me a z-score, which is the number of standard deviations from the mean. So as you can see here, I see a value of 70, but I don't know how many standard deviations that is away from the mean. If I standardize the data, and all we do to standardize the data is just take that data value, in this case 70, minus my mean, and then divide by the standard deviation. So this is standardizing. Again, very, very important. Standardizing, so I can just state how many standard deviations I am away from the mean. And then we love symmetrical graphs because, as you're going to see, these type of distributions have a lot of properties, formulas that we can use right away. We do have some, we typically don't get into in this class, but in later classes, what do we do if we don't have this type of a bell-shaped curve? We have some type of skewed data. Then there are other things that we can do, but again, that's kind of moving up to the higher level stats classes. One thing that is nice to know is if you have symmetrical data set, your mean, median, and mode are all equal, and that's kind of nice. But if you have, like, think about it, if your median, the middle, remember that was a 50% of your data, is higher than the mean, then you could see that skewness would start to happen, okay, over here to this side of the data set. And then, of course, if the median's less than the mean. All right, and then the last thing is Chevyshev's theorem. This is actually a way to find the proportion of any distribution. So it doesn't matter if it's skewed, that lies within k, being just some positive number, standard deviation of the mean. So this formula here would tell me at least, okay, this is a proportion, values would lie within this area. So you're starting to see this week, you're going to get more into formulas. Definitely, you're going to have to get down the terminology in this section, the symbols. Okay, so having a symbol sheet is something very good to have. But again, watch my videos because all these calculations you can do in Excel.